I want you to close your eyes for a second. Seriously, just humor me. I want you to picture this. You're 12 years old. You're sitting on the floor, legs crossed. You've been grinding through a dungeon for like 45 minutes. Your resources are low, you've got one health potion left, your palms are literally sweating on the plastic controller, and you step through that final fog gate.
I know exactly where you're going with this.
Suddenly, the music just shifts, the strings start swelling. There's this pounding, dissonant percussion. It's a boss fight. And before you've even pressed a button, before the monster even roars, your heart rate is already synced to that tempo. You are locked in.
Yep.
And then finally, after 20 tries, and maybe the throne controller, you land that last hit. The monster dissolves, and you get that triumphant jingle.
It's a Pavlovian response, isn't it? It is, and it's arguably the best feeling in the entire medium of gaming.
It feels like magic. It feels like the game knows exactly how you feel. But as we are going to find out today, it is very much technology.
Exactly. It's not just about a composer writing a catchy tune on a piano, but it's about how 40 years of hardware evolution, from tiny primitive silicon chips to massive AI processors, have completely dictated what we hear when we play.
So welcome to the deep dive. Today we're digging into a fascinating document simply titled The Evolution of Music in Games. And we're going on a journey. We're starting with the simple beeps and boops of the late 70s, and we're going all the way to the near future of AI-powered soundtracks that, literally compose themselves in real time while you play.
It is a massive trajectory. And the core thesis here, the thing I want us to keep coming back to, is that game music changes whenever the hardware opens a new door. The art is entirely dependent on the machine.
I love that concept. It's like the medium defines the message, or in this case, the melody. So let's unpack this. We're starting in the late 70s, early 80s, the era of the Atari 2600, the Commodore 64. Like everyone has a sound in their head when I say Atari.
Right. It's that very distinct electronic kind of crunchy sound. We call it chiptune now, and indie developers use it today for a retro aesthetic. But back then, it wasn't a style choice. It was a hard constraint. They just hit a wall.
Because the chips were tiny.
Microscopically tiny in terms of capability. You have to remember, memory was expensive. These systems had very little RAM. The sound chips could only produce a few simple tones at once. We're talking about maybe 3 or 4 voices or channels.
So if you wanted to play a chord, which is 3 notes, you've basically used up your entire orchestra.
You have. You'd have a channel for a square wave, which sounds kind of buzzy. Maybe a triangle wave, which is smoother, like a flute. And then a noise channel for explosions or rudimentary drums.
Yeah.
That was your entire toolkit.
And here's the part from the source material that really, it just blew my mind. The people making this music, they weren't just musicians.
Oh, yeah.
They were essentially computer programmers.
That's a crucial distinction. In 1980, you didn't have music software like GarageBand. You had to write code. You were dealing with hexadecimal values. You had to tell the chip, line by line, play this frequency for this many milliseconds at this volume. These sound programmers were equal parts artist and engineer.
Can you imagine trying to write a heartfelt melody but having to type it out in code?
It takes a special kind of brain. And because of those limits, only having 3 or 4 channels, they had to be incredibly clever. They used arpeggios playing notes really fast in sequence to simulate a chord because they couldn't play 3 notes at once. It's an auditory illusion.
The source mentions Space Invaders from 1978 as a major milestone here. But when I think of that game, I don't really think of a song. I just think of 4 notes. Ding, 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 ding.
It is simple, but structurally it changed everything. It was one of the first times a game used simultaneous tones to create a continuous sense of urgency. But there is a fascinating technical story behind why it sounds the way it does.
Do tell.
You know how the music speeds up as you kill the aliens?
Yeah, it gets frantic. My blood pressure spikes just thinking about it.
Well, originally that wasn't an artistic decision to induce panic. It was a quirk of the hardware.
What do you mean?
The processor on the arcade cabinet was very weak. It had to render the aliens and play the sound in a loop.
Okay.
When the screen was full of aliens, the processor was struggling, so the loop ran slow. But as you killed the aliens, the processor had less to draw. The rendering loop ran faster.
Which meant the sound loop ran faster. Wait, really? So the most iconic, anxiety-inducing soundtrack in history was basically a hardware glitch that worked.
In a way, yes. The tension was a byproduct of the CPU load lightening up. The developers realized it created this incredible emotional effect panic, so they kept it. And that set the stage for everything that followed. The idea that the audio should react to the game state.
That is wild. Okay, so we moved from the primitive chips into the mid-'80s, early '90s, the Nintendo Entertainment System, the Sega Genesis. The hardware gets a little beefier.
Right. We're stepping into the 16-bit era. The chips had more channels, meaning you could have a dedicated drum track, a bass line, and a melody all playing nicely together. But the biggest revolution here was MIDI.
MIDI, that stands for Musical Instrument Digital Interface, right? I feel like I see that on chords in my drawer that I don't know what to do with. But we need to clarify, MIDI isn't a recording, is it?
No, and that's a crucial distinction for the listener. Think of MIDI not as sound, but as digital sheet music.
Okay.
It's a set of instructions. It doesn't contain the actual sound of a trumpet. It contains a command that says, "Console, please play a C sharp on your internal trumpet instrument right now."
Which explains why the same game sounded different on a Sega versus a Nintendo. They had different instruments built into their chips.
Exactly. The Sega Genesis had a sound chip that was originally used in FM synthesizers, so it had that gritty, metallic rock and roll sound. The Super Nintendo used samples, so it sounded more orchestral and muffled. But this standardization allowed composers to finally work like composers. They could write complex arrangements that the console would interpret.
And this is where we get the most iconic earworms in history. The source specifically points to Super Mario Bros.
You can't talk about game music without Koji Kondo. But notice how the technology allowed for a shift in atmosphere. You have the upbeat overworld theme, everyone knows it, but when Mario goes down a pipe,
The game switches to the underground theme,
it switches, yeah.
which is simpler, darker, more echoey.
Exactly. The hardware was capable of holding different states for the music. It wasn't just one loop for the whole game anymore. The console was checking, where is Mario? And serving up the appropriate digital sheet music in real time. That's a huge step forward in immersion.
Okay, so we've got catchy tunes, we got different levels. But then we hit the mid-'90s, the PlayStation 1, the Nintendo 64, and suddenly the script just flips completely.
The CD era. This is arguably the biggest discontinuity in the history of game audio.
Because of storage.
Storage and delivery. A CD holds roughly 700 megabytes of data. Those old cartridges held maybe a few megabytes. For the first time, you didn't need the game console to synthesize the music using a chip. You could just record real music in a studio.
A real orchestra, a rock band.
A real orchestra, real vocals, a rock band, burn it onto the disc, and the console would stream it just like a CD player.
So this is why we suddenly went from Beep Boop to Final Fantasy VII sounding like a blockbuster movie.
Yes. The source highlights Final Fantasy VII as the turning point. You played that game, and suddenly you're hearing one winged angel with a full choir chanting in Latin. It was mind-blowing fidelity.
I remember playing that. It felt incredibly cinematic. But the source material points out something really interesting here. There was a trade-off. We got better quality, but we lost something in terms of interactivity.
That's the static problem. See, when you record a full orchestra on a track, it's done. It's a static recording. It starts at 0.00 and ends at 300. It doesn't care if you're fighting a boss or if you're stuck in a corner running in circles or if you've put the controller down to make a sandwich. It just plays.
Ah, I see. So in the old Mario days, because the chip was making the sound live, they could speed it up or slow it down easily. But with a CD track, you can't just speed up a recorded orchestra without it sounding like chipmunks.
Exactly. It broke the connection between the player's action and the audio. For a few years in the late 90s, games sounded incredible, but the music felt a bit like wallpaper. It was just playing in the background. I wasn't watching you play anymore. We needed to find a way to get that cinematic quality back, but make it intelligent again.
Which brings us to the 2000s, the era of adaptive audio. And this is where the source uses my absolute favorite analogy in the whole text.
Oh, yeah.
The pizza analogy.
I had a feeling you'd like this one. It's a really great way to explain how modern game music production works.
Okay, let's break it down for the listener. So instead of one big audio file, the composer creates stems.
Right. Think of the core track as your pizza dough and sauce. That's the bass layer, maybe the rhythm section, the drums and bass that plays constantly. Then you have the toppings. The melodies, the pepperoni, the hi-hats are the peppers, the swelling strings are the extra cheese. Each of these toppings is saved as a separate, transparent file that plays on top of the dough.
And the game engine is essentially the chef deciding which toppings to throw on the pizza in real time.
Exactly.
Yeah.
The game designers use software middleware like FMOD or Waitwise to set the rules. So a rule might be, if the player's just walking, give them the dough and the sauce. But then, if the player draws their sword, unmute the pepperoni melody.
And the source gives a really specific, kind of stressful example of a rule. It says, if player health drops below 30%, add a low, throbbing pulse layer.
We've all felt that. You don't even need to look at your health bar to know you're dying because the music tells you. That's adaptive audio. It's seamlessly mixing those layers based on what you do.
The source mentions The Legend of Zelda. Ocarina of Time is an early pioneer of this, shifting from calm exploration to battle music without cutting. But I want to talk about Portal from 2011.
Portal is brilliant because it used music almost as a reward system.
How so?
The audio was adaptive to your puzzle progress. When you walk into a test chamber, the music is murky, maybe just the bass. But as you solve parts of the room, hitting a button, aligning a laser, the music adds layers.
Oh, wow.
It gets brighter, it's subtle, but it subconsciously tells the player, you're smart, you're on the right track.
It's so clever. It's positive reinforcement through audio. And now we're seeing this get even more complex with procedural synthesis. Yeah. No Man's Sky is the big example here, right?
No Man's Sky is fascinating because of the scale. It has 18 quintillion planets. You cannot hire a composer to write a unique song for every planet. It's physically impossible.
So how do they do it? It's not just random noise, is it?
No, it's highly structured. They built what's called a music graph. They gave the computer a massive library of sounds, textures, and instrumental fragments, and then they taught it the rules of how to combine them.
So it's improvisation.
Structured improvisation. When you land on a new planet, the software checks the variables. Is the planet toxic? Is it radioactive? Is it peaceful? Is there life? And it builds a soundscape from scratch that matches that atmosphere. It's generating the track in real time based on the math of the environment.
So we've gone from chips to CDs to dynamic layers of pizza. But now we are standing on the edge of something completely different. The source calls this the future, AI and real-time generation.
This is where it gets really sci-fi. And we need to define our terms here, because AI is a huge buzzword right now. In this context, we aren't talking about a playlist algorithm or shuffling layers. We are talking about deep learning models that understand music theory.
So these models have studied thousands of songs, figured out how melodies and harmonies work, and now they can compose new original music on the spot.
Correct. Not just mixing layers like the pizza analogy, but actually writing the notes, performing the instruments, and generating the audio waveform in real time, specifically for you.
The source paints this picture of the role-playing game of the future that I just have to share. It walks through a scenario. Let's imagine this together. You walk into a desert area for the first time.
Okay.
The AI generates a sparse, windy melody. It's lonely. Maybe a solo cello.
Sets the mood.
You leave. You go save the kingdom, you level up, you become a legend, you come back to that same desert 10 hours later. The AI knows you're a hero now, knows your context. So it takes that same lonely theme, but plays it with a heroic, triumphant arrangement. Brass, percussion, the works.
That is the holy grail.
And then a sandstorm hits, and the AI immediately adds dissonant percussion and scary drones. And here is the kicker. None of this was pre-recorded. A human didn't write the heroic desert theme. A human didn't write the sandstorm variation. The game wrote it for you because it knew your context.
That is the transformative potential. It's what we call emotion-driven scoring. The game is constantly reading the room, reading your gameplay. Are you playing frantically? Are you playing stealthily? Are you hesitating? The AI shifts the mood of the music to match your exact emotional state.
It also mentions personalized themes. Like if I create a character with a tragic backstory, the AI could generate a sad leitmotif just for me.
Exactly. Or if you have a custom companion, every player's soundtrack would be theoretically unique. It moves us away from the soundtrack of the game to the soundtrack of your playthrough. Two people could play the same game and hear completely different scores.
That sounds incredible on paper, but I can see the expert wheels turning in your head. You're about to tell me the catch.
Well, we have to look at the practicalities. The source outlines some significant pros and cons. The pros are obvious. Endless variety. You never get sick of the loop because the loop never repeats. And storage, instead of 50 gigabytes of uncompressed audio files, you just store the small AI model.
Which is huge for indie developers or mobile games where space is tight.
Massive. But then, the challenges. First, there's consistency. A human composer knows how to keep a consistent tone. They know that a grim, dark fantasy game shouldn't suddenly sound like a circus.
Techno circus might work for some games, but I get your point. AI hallucinates.
It does. It drifts. If the AI suddenly decides to switch genres in the middle of a death scene, it breaks the immersion completely. That quality control is really hard to automate.
And then there's the performance cost.
Right. Generating high-quality audio in real time takes a lot of processing power. Every cycle your CPU spends composing a symphony is a cycle it's not using for graphics, physics, or enemy AI. It's a balancing act. Do you want better lighting, or do you want a unique song?
And we have to talk about the legal aspect. The source flags this as a major hurdle.
The biggest elephant in the room? AI models learn by ingesting existing music. They study patterns from Mozart, from Hans Zimmer, from everyone. If the AI generates a melody that sounds suspiciously like a John Williams score it studied, who owns that?
Is it original? Is it plagiarism?
We don't really know yet. And until that legal framework is settled, a lot of big studios are going to be hesitant to put this in a commercial product. They don't want to get sued because their AI accidentally rewrote the Star Wars theme.
And aside from the legal stuff, there's just player expectation. Sometimes I just want to hear the Halo theme. I want the thing I know. I don't want a variation. I want the iconic track.
That's a very human desire. We crave familiarity. We anchor our memories to these specific melodies. Think about the victory fanfare in Final Fantasy. If that was different every time you won a battle, would it feel as good?
Probably not. It wouldn't trigger that Pavlovian response we talked about at the start.
Exactly. A constantly shifting, never repeating score might actually feel unsettling to some people. It might feel like the ground is constantly moving under your feet. We might gain immersion, but we lose the shared culture of humming the Mario theme with our friends.
That is such a good point. If you and I play the same game but hear different songs, we lose that shared language.
You do. It isolates the experience.
Wow. So what does this all mean for us? Let's zoom out.
If we look at the big picture, the evolution of music mirrors the evolution of games themselves. We started with static, linear experiences. Go from left to right, jump on the flag, and the music was a static loop. Now, games are living, breathing, open worlds that react to everything you do. And the music is finally catching up to become a fully responsive partner in that ecosystem.
It's not just wallpaper anymore. It's part of the architecture.
Exactly. It's part of the game's logic.
So we've gone from the ding, ding, ding of Space Invaders, basically CPU glitch, to an AI conducting a symphony for you in a virtual desert. It's been quite a ride.
It really has. And we're just getting started with the AI phase.
I want to leave you, the listener, with a thought to chew on today. We talked about how AI can mimic emotions, making the music sad when you're losing or happy when you win. But here's the provocation. As this technology gets better, the line between music written by a human soul and music generated by a cold algorithm is going to blur till we can't tell the difference.
We simply won't be able to hear the difference.
Right. So in the future, when a video game moment makes you cry because the music is just so perfect, will it matter to you that no human ever felt that emotion while writing it? Will the soundtrack of the future be a responsive partner, or will we miss the ghostly touch of a composer reaching out through the screen?
That is something I'm going to be thinking about for a long time. Does art need an artist to have meaning?
Me too. Thanks for joining us on this deep dive into the sounds of our digital lives.
Thanks for listening.
Catch you next time.
Until next time, keep exploring, keep questioning, and keep diving deep. Thank you for listening to today's podcast. Please feel free to click on the link in the description below to discover more podcasts.